How's it going, everybody? Ooh, why did that adjust? 1 second here. I'm trying not to shout at you. There we go. How's it going, everybody? Try that again. Take two. So, in this video, welcome back to our Cisco Enterprise series. In this video, we will be taking a look at Internet Service Provider peering options for those of you that are interested and want to know what are your options when it comes to peering with ISPs. Now, we've already done this, and the same thing with network layer reachability information. You know, we've already sent network updates, so you guys have already seen that firsthand. I'm going to talk more about this from a kind of a design perspective as to how you go about going through the process of doing that. A little bit of the process itself, you know, what you need to do and all that good stuff that goes along with that. So just more or less some information for you guys, and then I'll scroll down here a little bit. There's going to be some configuration options that we're going to go through, but you really need to understand how to move forward with the initial peering capability. So typically speaking, there's 3 different ways that you're going to peer with an internet provider. Let me pull up my pen tool real quick. There's going to be, the first way is you're just going to get an internet circuit and they're going to deliver to your location, and that's going to be about the extent of it. Nothing spectacular. It'll get the job done, all that good stuff that goes along with it. So there's that. And that could be via fiber, it could be via coax. It really depends on the scenario at hand. So that's where, you know, you create a default route, or you get it could be business internet, but, you know, there's a DHCP, or you might, so you would get commodity internet, right? It would be delivered via fiber or coax, and you may or may not have a static IP. Depends on the scenario at hand. So that's the most basic one. Like the most internet provider connections that are out there are going to be commodity internet. There are scenarios where you could go and get a enterprise class internet circuit from any one of the big ISPs, whether that's AT&T, Lumen, Spectrum, trying to think who else is out there that's big, Verizon, so on and so forth, Comcast, depending on where you live. I'm sure there's other internet providers that are out there. Those are just the ones that I can think of off the top of my head. So you have these situations where you would get the circuits delivered to your location. You know, usually pretty easy to work with. That's the easy button for doing internet connectivity and stuff like that. Doesn't require you to do any peering. You may get a DHCP handoff from the provider. They give you a public address like I have here at my home. You know, I've got a public IP address via DHCP. Everything, it works out great. I have no problems with it. Now, on the flip side of that, the more complicated way, there's technically 3 different ways that can go, right? We've already talked about the first one, and that one is where, well, technically there's 4, right? You've got your commodity internet, and you just have a static route that points to the next top public IP address. Fairly simple. If you actually want to do any level of peering itself, there's a couple different ways that you go about doing this. I don't care if it's coax, I don't care if it's fiber. Typically speaking, though, it's going to be fiber. Most providers are going to give you gigabit internet, stuff like that. Now, when we talk about it from that perspective, the way that this usually works is you're going to have your 3 different peering options, right? You're going to either have the first one. Why is that all of a sudden not working? It's like, I don't understand it. It's just weird how it will flake out on me. There it is. Okay. So the first one we have, the first one here is going to be a real simple one, right? Where you do a BGP peer and you get plus default route. Okay, fairly simple deployment method. Everybody's happy with it. Everybody's good. The second one is going to be BGP peer, and you get the default route plus provider. Oops, it's supposed to be a P. P routes. That's supposed to be an R. What do I mean by P routes? P routes or provider routes are the routes that the provider owns and advertises to you. So that could be, if it's AT&T, it's going to be the 12 network. I don't know any of the other big carrier subnet ranges, but that's essentially what you would see. You get a BGP peering, you get a bunch of 12 subnets that would start showing up in your routing table, and the default route. The third one is going to be BGP peering and full table. The full table may or may not include the default route. So with those options in place, you have some things to take into consideration. Where do I want to move forward with that? How many peers do I need to provide peer to? All that. These are all really good questions that need to be understood in terms of their day-to-day operations. Now, speaking of how this comes into play, if you've never done a public autonomous system with a /24 public address space to a provider, there is a process for that. I talked a little bit about this in the network fundamentals section, what you'd have to go through and do. So at a high level, there is the process of, depending on where you go. So in my experience, I've done this about a dozen times, and typically speaking, what I would do with the customer is we would go out and we would get them go to an auction house like IPv4auctions.com, for example. You can go to this website and you can they'll charge you based off the subnet size. So there is a per IP cost. So for example, let's say a /24 public address space will cost you $2,500. So that money has to be paid to the auction house. And that auction house works very similar to the way eBay does, where you win the election, or you win the bid, right? You win the auction. And then unlike eBay, where you go and you've paid for it and you've paid the shipping and handling, and then within a week or two, whatever you won in your auction magically shows up to wherever you're at. The way that it works with IPv4 addresses is you need to have an ARIN, A-R-I-N, the American Registry of Assigned Numbers, I believe is what ARIN stands for. It's a standards body that's out there like IANA, stuff like that. You need to have a number of things in place within ARIN in order for this to work. And essentially the idea here is somebody already owns that address space, right? That /24 was already bought by some other organization, and now you need to go and have it transferred from their organization over to your organization. In the process of doing that, you have to come up with justifications. Typically, it's going to be a spreadsheet that you can work with to say, okay, out of this X amount of IP addresses, I'm going to be using a chunk of them to do this justification with, and that would, at least that's how I've done it in the past. And you'll use that as your justification. You'll upload that to ARIN's. There's like a portal you can log into, and you'll have to go through the justification process. You'll upload the spreadsheet. The spreadsheet will have the address space that's in there, and you'll be able to say, okay, this is the reason why I need a /24. This is the reason why I need a public address, a public autonomous system number. That whole process that goes into it. It does take some time. It doesn't happen overnight. You're looking at probably, last time I did it was a couple years ago, and it was about a month and a half process, as long as there's no hiccups, where you have the transfer of ownership between that public address space and your organization inside of ARIN. Now, that's only one piece of it. Once you've gotten this address space to move between organizations, and now it is lawfully yours through ARIN, right? It's owned by whoever it is you're working with or for. Then you have a whole other set of problems to deal with. In order for you to be able to go out and advertise routes and things like that, you need to go with a provider that's going to be willing to do that with you. Most providers are going to be pretty easy to work with, and you'll have to do what they call an LOA, or a letter of authorization, and say yes, you're going to allow them to peer with you, all that good stuff that goes along with that. And then depending on how the provider goes about doing the process, they may do the work for you, or they might help you with it. It depends on the scenario. But there's this thing called a RADB, the Routing Advertisement Database. And what RADB, or there's another one out there called RPKI, and it depends on the scenario you work with. But typically speaking, when you're working with these type of scenarios, you have to go through and work with the standards bodies to get your address space to be publicly recognized, so that the public internet routers can actually propagate your network where you want it to go. Now, there are a multitude of scenarios to walk through. I'm not going to walk through all of them. I don't have a way of demoing this. I can only tell you what, from my experience, what I've had to do in the past. And, hopefully you don't have to, you can do what you need to do. But in typical, it's one of those things where you have to go through it. It can be challenging at times and make you scratch your head and why are things so difficult? But just understand that's the process. So when we talk a little bit about that, so that process is actually relatively straightforward, right? You have your peering and your default route. You have your peering plus the default route plus the provider-owned routes, and then you have the peering plus the full table, which would include, if you have the full table, then there's no need for the default route. And if you have no default route, it's actually called the default free zone, meaning that you have every route out there. And the last time I checked, there was a little over 800,000 subnets in the global BGP table. So that's a lot to think about. Now, let's talk a little bit about how this process works when it comes to single-homed. So single-homed is how we're actually doing a lot of our connections here. If you look right here, R33 is single-home to R26, right? That's a single-home. Now, technically speaking, R34 to our XR42, this is a single-home connection, right? We only have one link out to a provider. R33, actually, let's talk about R58 and R59 are technically dual-homed. So single homing means that you have one connection to one provider, where a dual homing, in this particular case, means that you have one or more routers connected to at least one provider. So this is a very common design that I've deployed multiple times, where you have two edge devices and you peer to the same provider. The last one is what they call multi-homing, and multi-homing is R33. Multi-homing means you have one or more routers peering to two or more different providers. So in this case here, I've got R33 is peered to ASN1 and ASN3. So we'll be able to form BGP peerings over both of these and get the connectivity in place that we need to. So that's what we refer to as multi-homing, where you've got more than one peering out to two different providers. So could you have all four of these routers all peered out to ISP? Yeah, you sure could. 100%. There's nothing that stops you from doing that. And what would it take some time? Yeah, it would. There's a process to that. And one of the last steps in that process is actually having the provider on the phone when you're making a configuration change, and they're doing the config. You get the BGP peering up, and then you advertise the routes that you need to advertise. That's the easy part. The configuration of the router, that's the easy part. The hard part is getting through all of the legalities and stuff like that. Been there, done that. I won't show you the justification process for that, because of the fact that there's spreadsheets out there that you can work with that'll help you out with that. But that's just some of the basics to it. So let's go back over here. So again, single homed, you have a single internet facing router that forms an eBGP peering with a single ISP. Single dual home is you have one or more internet facing routers that forms an eBGP peering to two or more ISP routers. Single multi-homed is you have one or more internet facing routers peering with two or more ISPs. And then you have dual multi-homed is you have two or more internet facing routers that form eBGP peerings with multiple ISPs and multiple ISP routers. So that's where it really comes down to play of how do you plan on doing your peering design. So is there a right way versus a wrong way? No, there isn't. What's nice about this is when you have these options, you can go talk to folks like myself or engineers that have been doing this for a while that understand how BGP peering processes work and walk through that process. So once you're there, it's pretty easy to work with. So there, that kind of brings back a point that I made earlier in the BGP section of the difference between provider independent and provider aggregation. Provider independent means that you own your own address space, you own your own autonomous system number. In most cases, there are scenarios where you could own your own address space, but not own your own public address, or I'm sorry, autonomous system number. And then the provider can give you a private AS, and then you can form a peering with that. They would just strip out the private AS in BGP. It's called remove private AS. It's an actual command we can use. So there's that. Provider aggregation is no different than commodity-based internet, right? You end up getting a connection to them and you form via BGP, or you don't even have to form via BGP. We actually demoed it on right here when we were doing some DMVPN, where I've gone through in the beginning of the BGP section where we advertised a bunch of these subnets. We didn't advertise them from this router, we advertised them from the provider. So when the provider's doing the advertisement for you, that's provider aggregation. So they're doing the advertisement for you, which makes your job that much easier to work with. So that, ladies and gentlemen, is pretty much what I want to talk to when it comes to peering processes and things like that. I know in the BGP section, we've already talked a little bit about how that works and next hop updates and troubleshooting and things like that, the peering types. But I just want to have a little bit of a design discussion with you guys when it comes down to how that all works. So, and I'm going to talk a little bit about in the next video about how BGP NLRI origination works, because we need to definitely understand that, how that comes into play when it comes to doing route origination and things like that. And then we'll get into some more interesting topics as we go along. So if you have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.